Hello, Legacy Sabers. We are starting a new unit called Special Functions. What you're going to need today are your notes and your listening ears. We have a foldable that's going in our notebooks. It should look like this. It's kind of a diamond shape. We're going to be talking more specifically today about the domain and range of special functions. And so as we see on the front of our foldable, the domain is the same thing as all the x values of our function, and the range is the same as all the y values of our function. Or remember, we've also called it our input is the domain, and the range is our output when we're talking about a function and a function machine. So domain and range, remember that when we identify them from ordered pairs, all we're saying is that the domain is the x values, like I said, of the ordered pairs. So in this case, it'd be 2, 4, 6, and 8. And the range would be the y values of the ordered pairs, which is 7, 11, 15, and 19. So keep that in mind when we talk about domain and range. Remember what we've already talked about in previous lessons and in Algebra 1, that domain is all of our x values and range is all of our y values. Okay, so we're talking about domain and range from a graph. So we have 3 bullet points that we need to get down inside of our foldable. The first being that sometimes it's not possible to list all of the x values and y values like we've done in the past because the graph is made up of an infinite number of points, or we also can call that a continuous graph. So like the example we saw on the previous slide, we had ordered pairs, so we could just list what the x's were or what the y's were. So from a graph, if we have a continuous function or a curve, then we're not going to be able to just list all of the points. So in order to list the domain and range, we can't just list the single list of points. Instead, we're going to have to list them in an interval of values. Remember, interval notation is like less than or equal to, greater than or equal to. So we're going to use that notation to list our domain and range of the graph. And lastly, we look at the graph and read it as it says in terms of x and y values. Then we write the inequality statement for x values and for y values to describe what's going on with the graph, okay? Also, as always, when we read graphs, we read them from left to right, so make sure that we understand that as we look at the next 3 examples. Okay, so example number 1, we want to write the domain and range using inequality notation. So the domain, that's all of my x values from the left all the way to the right. So it's all of these x values on my graph, okay? So we're starting from this point, which is negative 1, 2, 3, 4, and we're going to x is equal to 2. So how we're going to write that in inequality notation is we're going to be using an and inequality or compound inequalities, right? So we're talking about x being between the values negative 4 and 2. So when we read this, we say negative 4 less than or x, which is less than or equal to 2. But if we just break it up into two inequalities, we're saying x is greater than negative 4 or equal to negative 4, and then we're also saying x is less than or equal to 2. Okay, so that's what we're doing. If we want to talk about the range or the y values, that's starting from the bottom. So if we look at the bottom, we're starting at negative 2 on the y-axis, and we're going all the way up to positive 4. So it's this axis, the y-axis, and we're between these 2 points on our y-axis. So like I said, we're starting from the bottom up, so that's negative 2 all the way to 4. So my range would say negative 2 is less than or equal to y, which is less than or equal to 4. That's how we would write it, but what we're saying is that x is between those 2 values and y is between those 2 values. So we have to think about what we're trying to say and then what's the actual notation to write it. Like we know x needs to be between negative 4 and 2, so we write it this way, and then we know that y needs to be between negative 2 and 4, so we write it this way. So we used and inequalities to show that. Okay, so example number 2, same thing. We're starting on our x-axis at this point and we're going to this point. So we're starting at x is equal to negative 7, and then x is going to be between that value and 1, 2, 3, 4, 5. So we're between -7 and 5. But we want to remember when we are talking about inequalities, when we have less than or equal to or less than, the line underneath is telling me that it's a closed dot. So I need the less than or equal to because we have a closed dot at the x value -7. But then at the x value of 5, we have an open circle or an open dot, which means that this is just going to be less than. Okay? So now when we talk about the y values, we're here on our y-axis all the way up to here. So we're at y is -3, or y is between -3 and 1. And so there's a close circle at y is -3, so that's going to be less than or equal to, because it's a closed circle. And then we have an open circle at y is equal to 1, so that's just going to be less than. So my two inequalities, so for my domain is -7 is less than or equal to x, which is less than 5, and my range, which is -3, less than or equal to y, which is less than 1. Hopefully the inequality notation is making sense. We're just using and compound inequalities, where so our variables in between those two symbols. Example number 3, the last example for our notes today. It looks a little different. First of all, our graph is continuous, so what we're saying is that it doesn't stop midstream. So once we start drawing from the origin, we're going all the way this way for forever and ever. So we're going positive for forever in the x direction, and we're going positive for forever in the y direction, or we're getting bigger on the x and the y. So for my inequality notation then, instead of doing an and inequality like we did on the last two examples, or a compound inequality, I'm just simply going to say x is greater than or equal to 0, and for my range, y is greater than or equal to 0. So this one was fairly simple. Hopefully we can see how the inequality notation is working into the domain and range from graphs of special functions. These special functions can sometimes look super crazy and funky, so we'll get more practice with them in class, and this video just served as an introduction to this topic. So I want to thank you all for taking such good notes, and I shall see you soon.